Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
What? Hey! Hey! Who turned off the lights? I'm in here.
I didn't touch anything.
Well, now I'm brushing my teeth in the dark.
Okay, that was me. I was just trying to turn on the mirror light.
Why would the mirror light control the bathroom?
Can we not solve this right now?
What do you mean?
We are late.
Who turned the lights on? I'm changing.
I swear I'm not touching anything.
Okay. Don't move. Nobody move. Hey, they're waiting downstairs. Come on.
I just wanted to wash my face.
What happens when every room invents its own rules? When a switch looks like a light, but acts like a TV remote. In the physical world, we call that bad wiring. On the web, we call it breaking the pattern. And when we ignore established interaction patterns, users don't feel empowered. They feel lost. This is a trap I want to talk about today. Ariel here, and welcome back to Web Accessibility for All.
Why ARIA knowledge is not enough.
No.
Let's start with something I see all the time. A developer tells me very confidently,
I know ARIA.
and usually they do. They know the roles, they know the attributes, they know which ones goes together.
But the interface is still broken.
Keyboard users get stuck. Screen reader users hear the wrong thing at the wrong time. Focus moves when it shouldn't, or doesn't move when it should. Nothing is technically invalid, but everything feels wrong. Patterns are what keep us from inventing behavior every time we build a UI. They define how something works over time, with the keyboard, with focus, with assistive technologies.
What are headless component patterns?
What?
Before we go any further, I want to clarify what I mean with patterns in this episode. I'm not talking about visual patterns. I'm not talking about component libraries. A headless component pattern defines behavior without prescribing presentation. It answers questions like
how focus moves, how the keyboard behaves, how state is managed over time, and how users enter and exit an interaction.
headless patterns exist above frameworks and below design. They are the contract between interaction and implementation, and this is why they are safer than learning ARIA in isolation. ARIA tells you how to describe a role or a state. Headless patterns tell you when that role makes sense at all, and what behavior must exist for it to be meaningful. In practice, headless patterns usually show up as a set of required keyboard interactions, a focus model, a small number of allowed states, and very strict rules about what must not happen. If you remove the styling, remove the framework, and remove the branding, the pattern should still be fully understandable.
Case study. The filter that wasn't a menu.
Let's look at the classic disaster. The filter that thinks it's a menu. Imagine a search results page. You have a filter button. You click it, and a list of options drop down. Books, products, articles. On the left, there is a filter panel. Format, language, publication year. One of those filters opens a drop-down with 20 options.
So when users click on Format, they get a drop-down with check marks. They can pick one option and the results update.
Got it, that's a menu. I'll use a menu pattern. Keyboard support comes for free.
Perfect. It should feel fast, like a command.
Wait, if I open it with the keyboard and move up and down, am I navigating commands or am I selecting a value?
Well, both. You choose one and the page updates.
Does the choice persist if I reopen the filter?
Yes, it shows a check mark.
Then it's not a menu.
This is where headless patterns start to matter. Menus are about actions. You activate something, it runs, and you're done. On the other hand, filters are about state. You choose a value. That value sticks, and it changes the context of the page. Those two ideas look similar on the screen, but they behave very differently for users, especially with assistive technologies.
But it looks like a menu, and Roll Menu works fine with a screen reader.
It announces menu item. That tells users they're triggering actions, not setting a filter.
I want users to feel like they're narrowing results, not launching commands.
Exactly. Right now, the pattern is lying.
That's the key moment. Nothing is technically broken. The ARIA is valid. The keyboard works. But the headless pattern is wrong. Filters are not menus. They are selections. They represent state that persists beyond the interaction. This is exactly why following patterns scales better than learning ARIA.
Where accessibility patterns actually live.
What?
When a team says,
We follow accessibility best practices.
they usually mean,
We are copying behavior that users have already learned from their operating system.
and that is not a bad thing. That's how patterns work. A headless component pattern is something that has been implemented multiple times before. And if you look closely, you will notice something interesting. The best accessibility patterns are often undocumented. They exist as
This is the only way we're allowed to build filters.
Don't touch this keyboard logic.
If you change this role, QA will reject it.
patterns also live in constraints. For example,
We never override native keyboard behavior. We never use role equals menu for site navigation. We never add ARIA unless a real accessibility gap exists.
those are patterns too, negative patterns. A good headless component pattern gives you decisions that were already validated.
How to follow accessibility patterns safely, and when not to.
Yes!
Following a pattern safely starts with a very simple question. What user expectations does this pattern protect? What behaviors users already expect when they land on it? For example, if users expect Tab to move forward, don't introduce arrow key navigation. If users expect links, don't replace them with commands. If native HTML already works, don't simulate it. Now let's talk about when not follow a pattern, because patterns are contextual. A pattern that works beautifully in a data-dense desktop app can be actively harmful in mobile. A pattern designed for power users can overwhelm casual users. This is why strong teams treat patterns as defaults, not laws. You follow them until the user goal changes, the input model changes, the context changes, and when you do deviate, you do it consciously. You document it, you test it harder, you assume risk. At this point, a very reasonable question comes up.
So, how do you actually know what users expect? Should we copy what other companies are doing? Should we run A/B tests? Should we talk to disabled users early?
And the answer is yes. But not in the way most teams think. When you see the same interaction pattern appear across operating systems, browsers, and assistive technologies, that's not design conventions by accident. That's collective validation. Disabled users are not there to approve visuals. They are there to reveal broken assumptions. They will tell you things like,
I would never expect this to be interactive. I wouldn't even try to open this. This looks like a filter, but behaves like a command.
What headless patterns look like in practice?
let's go back to the previous discussion about search results filters. A solid headless pattern doesn't say,
Here's a drop-down with checkboxes.
It says,
Filters are groups of related controls. Each filter has a clear name. Changes announce themselves politely. Focus does not jump when results update. Keyboard users can move, apply, undo, and continue.
That's the pattern. A headless pattern doesn't start with ARIA roles. It starts with questions. By the time ARIA enters the picture, most decisions are already made.
Where headless patterns fall short, and why they're not a silver bullet.
Oh, yes.
Headless patterns reduce risk, but they do not eliminate it.
Context blindness.
Headless patterns are tested in one context, and they often break when you move it to mobile, dense content, or multiple languages.
False confidence.
Teams adopt a headless pattern and assume accessibility is handled, and that's dangerous.
Pattern drift.
Small changes and exceptions slowly distort the pattern until it's unrecognizable. That's when teams need to slow down, because headless patterns are starting points, not end points.
Wrapping up.
As you see, you can know every ARIA rule by heart and still build something unusable, because accessibility doesn't fail at a syntax level. It fails at the expectation level. So if you are a designer listening to this, don't just ask, what does this look like? Ask, what does this behave like? If you are a developer, resist the urge to build clever abstractions. Boring, predictable interactions are an accessibility feature. And if you are in QA, don't just check roles and labels, question the pattern itself. Because the most dangerous accessibility bug is choosing the wrong interaction model. And if there's one thing I want you to take away from this episode is this: learning ARIA is useful. Learning patterns is safer. Thanks for listening to Web Accessibility for All. If this episode was useful, share it with someone who just discovered roles or labels in ARIA. In the next episode, we will keep digging into the real-world decisions that make or break accessible interfaces. See you next one. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.